Okay guys, so let's take a look at A here. Basically, remember you want to try to find a pattern if there is any. In this case, I could see that they are increasing by addition. So this is going to be arithmetic. Okay. And then the explicit formula means we're going to pick this. Remember, to actually keep the formula, you leave n in there. So we're going to do that next. And then that's first term plus parenthesis n minus 1 times our common difference, which is 5. So that represents the arithmetic sequence. Then from there, find the 15th term means we're going to plug 15 in for n. And then just use the calculator. And I got the 15th term was 74. Versus, let's look at B here. You could see this pattern is times 2. So that makes it geometric when it's a multiplier. The explicit formula for that is right here. You don't have to memorize these three guys. That's why it's put there. So I'm going to put an equals first term, which is 1, times our common ratio, which was that multiplier, which is 2, to the n minus 1 power. So that is the explicit formula. Then we're going to use that by plugging 15 in for n, because it wants the 15th term. Equals 1, parenthesis, 15 minus 1. Now be careful, for some of your TI-83 calculators, you probably have to put this exponent in parentheses. Okay, so be careful about that. And I got 16,384 would be the 15th term. Okay, so that's a little review of arithmetic or geometric, the basic formulas. You don't have to memorize what's there. Okay, it's going to be given to you for assessments. Let's look at number 2. Given this sequence here, determine the value of S of 8. Now remember, this is series, which also means the sum. Okay, so series and sum, and that's what we were working with last class. So that's this formula right here if it's geometric. If it's arithmetic, then you need to use your notes to get the other formula, because that's the one you have to memorize. So let's see if we can find the pattern first. 40 to 10, so it looks like it could be, I mean, it's starting to get smaller, and it's clearly not subtracting the same amount, so it's probably geometric. If push comes to shove, you do second number divided by first. So 10 divided by 40 is 0.25. And I could do the same thing. 5 halves divided by 10 is also 0.25. So you can see here, okay, I know it's a little, there we go, that the common ratio is 0.25. So we're going to use the geometric series formula to find the sum of the 8 terms, okay, in this sequence. So we're going to write S of 8 equals first term, that's what A1 is, so 40 minus 40 times our R, which is 0.25, and to our nth, which is 8 numbers, over 1 minus 0.25. Now here's your hint. When you put it in your calculator, put the entire numerator in first, okay? So, and I'll even demonstrate that for you here. 40 minus 40, parenthesis, 0.25 to the 8th. Okay, so you can see this is a really weird number, right? Put that in first. Then when you hit divide, make sure that you put this in parentheses. And there, it says round your answer to 5 decimal places. So it's going to be 53.33252 would be the sum, okay, for the first 8 terms of the sequence. So we're going to be practicing those formulas a bit more. Let's look at number 3, where we started doing exponential graphs, okay? So again, when it says what type of function is it, it's exponential. And the whole reason being, how do you know, is because x is in the exponent. When your x value is the exponent, guys, it's going to be an exponential graph. Now, growth or decay depends on the ratio, right? That's this, our base. Since this is bigger than 1, it's going to be growth. But if it was like 0.75, it would be decay. So how do you know? The ratio is greater than 1. That's how we know. Shifts from the parent function. Shifts go into that A, H, and K. So remember, H is always here, but it's opposite, and it's the one that moves left or right opposite. So it looks like a +1, but really that's going to be left 1. So it's going to be left 1, all because of the H, and then here's your K, which is the up-down. Remember, it's going to be consistently the same, so this would be down 2. If it was a plus, it would be up. If this was a minus for H, it would be to the right. So start memorizing those rules again. They're just the same as the last marking period. So let's talk about this asymptote. Remember, all these graphs have a horizontal asymptote, and it's always at the K value, right here, because it shifts. Now that means the graph's going to be approaching that. So if I even give a little sketch here, and we go to here, this right here, our graph is not going to cross. It'll be something like that, where it's going to kind of sit right on top of it, but never actually touch y equals -2. The horizontal asymptote for these is always a y equals equation, always. And where do you find it at? It's that K value. Here, the domain for all of these graphs is all real numbers. And the range is from your K value. You can see the range being y values, it's not going to cross -2. So it's from -2 to infinity. Now remember, you always use a parenthesis because a parenthesis means it's approaching it but never actually reaches and touches it. Same thing with all the infinities. You always use a parenthesis. So today, we're going to be taking out our notes, okay, and finishing and doing some application about growth or decay. Okay, so keep your homework for now. I'm going to be checking that along with today's homework, both sets, on Friday. But for now, take out these notes. The next video I have is going to go through these, and we're going to do some application of exponential functions today.